Okay, in this video we'll continue from the last one where we did a development of a truncated cylinder and we did a development of a truncated hexagonal prism. Just a reminder, in this topic of developments, you can have developments of cylinders, cones, prisms, or pyramids. So prisms and pyramids have bases which are polygons. You can have a triangular pyramid, you can have a square prism, you can have a hexagonal pyramid, you can have a pentagonal prism, but when it comes to a cone and a cylinder, the bases are circular. So what we're going to do now is we will just draw a development of a cone and a development of a pyramid. So basically that is what we'll do for this video. So we'll start off with the cone at the top. And we'll just copy the size of it far below. Okay, so as I said, CXC would usually give you a truncated figure. They can give you a development of a full cone. What I will do is I'll do a full cone first, and then we'll do a truncated cone. But a cone has slanted lines which go to the top, and the top of the triangle is called the apex. So to complete development of a cone, it is similar to the cylinder, where you divide that plan view into 12 parts. So then once we have our 12 divisions, we should have these numbers similar to what we did last time with the cylinder. So they're numbered the same way, but the point is that when you project upwards, you must project towards the apex. So this is a big difference between the cylinder and the cone. With the cylinder, those lines come straight up to hit the top. The top of the prism and the pyramid, the top of the pyramid and the cone is this apex. So you project across to that apex. So we touch the bottom, we project across. Now when it comes to making our development, you would not stretch a line across. You would use radius, come from the apex, and you scribe to the bottom of the actual cone. So this is the line that is going to unravel to make the cone. We go back here and we use the space between the divisions. So we will copy this across. So here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So where these lines hit the actual edge, that curve that we made from the circumference, those will be our divisions. So you can copy them across. And then we will just delete these. Alright, see you. So we should have our 12 divisions now going across. Now we can number them. Now CXC may not ask you about numbers or anything, but this is important for you, those persons who are going to practice this and who actually take the time to draw it. It's not difficult to draw, but it can be helpful or will be helpful for you in doing the exam. So simply what I'm doing, numbering the different points as they are projected across and upwards. Alright, so it seems like I missed one. Okay, so those are our 12 points. Now, the last thing you would do, or the second last thing, now we have these points coming across. In the cylinder, you would have drawn your lines up to meet the edge of the top of the cylinder. But for this, you would use the apex. So you would connect these points to the apex. And this figure from 0 to 12 would be the development of our cone. Now I am using double lanes. This is just for the sake of time, but you should delete those lines. Now our development of our cone would be, as I said, from 0 to 12. So these lanes which are red, this is our development here. So if I had to draw this figure and cut it up, when I roll it together, it would make that cone. Now the problem is, well, not the problem, but CXC would like to challenge you. So they may give you a particular cut inside of the cone. For example, like this. So we truncate the top of the cone, and even when you're truncating the top of the cone, you will still draw the apex. And the reason for that is because, remember, all of the points must be extended from the base towards the apex. So now that this figure is changed, the difference that we would have here is you realize that these points here are at the bottom, at the top of this area. So we now have to pull these straight across. Now, when it goes back to our numbers, as was done with the first circle that we did over here, we number it the same way. And once again, this would help you in the construction. So 0 comes up, 0 hits here, 0 hits here. So 0 and 12 are the same point. So this point here is 0 and 12. Now what you would do is, you know that 0 and 12 hits here, so you draw it straight across horizontally until it hits this right edge. So Remember, this point is 0 and 12. So where it hits the radial line for 0, which is here, that would be your 0 point. You would then use a radius and you scribe the arc. So where this point hits 12 as well, that is your 12 point. So now we're going to do 1, 2, and 3. Realize that 1 is here, 2 is right here, and 3 is right here. So let me just highlight them. So once again, you project these across. So where they hit the edge, you can also number over here, but it's important to follow the line. So this line is for 1, and we open our compass from 1 down to where 1 hits. So wherever that point for 1, remember it comes across here, 1 and 1 line up. So 1 lines up with 1 here, and then 1 and 11 are the same point because 11 comes up. So 11 would be here. So we do the same thing for number 2. Scribe our arc where 2 hits. We do the same thing for number 3. Scribe our arc where 3 hits the edge. So I'll just trim it so that it's a little cleaner. But the point is that what you are doing is you draw across your line where it hits the edge. We then use our radius to follow it. So 2 comes across to 2, 3 comes across to 3, and 2 and 10. So we have our 9. So I'll just draw across the other points a little faster. So 4, 5, 6. So here is 4. Here is 5. And 6 already hits the edge of the figure. So remember 3, 4, 5, 6, 7, 8, 9, and it goes back that way. So here will be my point for 4, my arc for 4. Here will be my arc for 5. And then the last arc, here will be my arc for 6, which is the top. So remember that I did not put the numbers on the top of them, but you should be able to see and understand where the numbers are. So just copy up 4 and 5, but up here, 6 will be this last point, 7, 8, 9, and it goes back. So I'll just fill in the remainder of the points. Now this point here is 3. 3 lines up with 3. 4 comes across here, it lines up with 4. 5 comes across here, it lines up with 5. 6 is at the top, it comes right across and it lines up with 6. 7 should line up with the same 5, and then 4 should line up with 8. So we have our points for our spline, which we're going to make now. Then we close it. Then we just trim off the edge. So here now is the top of this development of this truncated cone. And the only difference is that this line that was red before, that was solid before, this will not be solid anymore, because you would realize the top of this cylinder, the top of this cone, is not solid. It has been truncated. So I'll just turn off the construction so we can take a look at it. And this here is the development of the cone. So if I had to cut this out and fold it together and stick it, it would make that truncated cone. Now if there was a cut at the bottom, like this, you would still see numbers at the bottom, and then we would project these across, and we would show the bottom of we would scribe these lines across as well. So the same numbers would apply if we had to cut it at the bottom here, and then we would scribe these across and we'll plot our points coming across. Now we're going to move on to the pyramid. Now because we have already done a truncated cone, we're going to just truncate this pyramid one time. So I want you to realize that I have two cuts. I'm not going to do fully the full cut, but I'm going to cut it at the bottom. So this pyramid here, we're going to make a square pyramid, very simple one. And we did a hexagon over here. We can do the square similar. So this square pyramid that we're going to draw, realize it has 4 points. 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So once again, you would project those points upwards to see where they hit. So 0 would line up there. Over here, now this edge is going to be solid, and I want to make clear that we understand this edge. You realize that there's a corner of the square here. So this corner is going to be a solid line here. Excuse me. And what we will do is we just construct, we just project up. So once again, it's similar to the cone, and that is one of the similarities between the pyramid and the cone, is that you bring your radius, you draw a circle here, and now you have to plot how many sides. So it's critical for you to plot the number of sides correctly, unless this figure is going to be off. So you don't divide the polygon into 12, because the polygon has its own number of sides already. So all you need to do is plot the corners, 0, 1, 2, 3, 4, 0 comes up here, so here is 0, and there's 0, and once again we project to the apex. So 1 comes up, hits here, so we have 1 at the bottom, right here, this point, and then we have 1 at the top. We then have 2 at the bottom here, and then a top here, and then 3 lines up with 1. So 3 and 1 are the same point. And then 4, which is the last point, 4 comes up with 0. So 0 and 4 are the same point. And now we're ready to plot the base of our development. So once again, you come from 0 to 1. This is the length of the side. So we have just transferred this length. We use a circle to transfer this length. So we copy it. We come here 1, 2, 3, 4. So in this one we use our points. So that's our point for 0, point for 1, 2, 3, 4. So how do we know we have all the points? You go back to the plan view, 0 to 1, 1 to 2, 2 to 3, 3 to 4, 0 to 1, 1 to 2, 2 to 3, 3 to 4, and then we connect from the apex down. Now the only reason I'm going back up is for the space of time, but understand that I'm making a double line. Alright, so now you project the point across. So we already have 0 coming across, and it's important to remember this for the pyramid, because for the pyramid you need to understand or remember that the base of the pyramid, like the base of the prism, is solid. So 0 comes across to 1. So 0 goes up at this angle to 1. We need to project 1 across to hit the edge. And then we use radius to scribe. So please note, 0 comes across here. So we have 0 already. So then we're looking for, where is 1? 1 comes across here. So that's our 1. So now we need to scribe our arc for 2. So let's just go over. 0 comes straight across, 0, 1 straight across, we have our curve, meets 1, 2, we have our curve, comes up here, meets 2, so then 3 comes here, comes across here, meet 3, and then we already have 4 at the bottom. So now with the pyramid, you connect these points or these edges together. Alright, so what you should see, 1 point here lines up with the 1 over here. And that is the bottom of our pyramid. Let's do our top. So 0 has to come across. 1 and 3 have to come across. We already have 2 here. So we're just doing 1 at a time. 0. So our point for 0, 0 at the bottom is here, 0 at the top is here. Remember that 0 and 4 are the same point. So our 4 point is over here. And now we're going to look for number 1. 1 at the top comes here, so we need to scribe our arc over there first. So here's our arc for 1. So our arc for 1 goes across, and then we look for where is 1. The 1's line up, and 1 and 3 are the same point. So now our last point now, which is 2, comes over here to 2. So 2 lines up with 2. So now once again with our pyramid, you use straight edges. So you realize that I'm not using a spline. And so I have my edge there, and this edge would now come up here. So let's take a look at what the development of the pyramid looks like so far. So here's what our development looks like. If we cut it out, it would make that shape, but how do we know it's correct? 1, 0 to 1, 0 to 1, 1 to 2, 1 to 2, 2 to 3, 2 to 3, 3 to 4, 3 to 4. So you would know what the figure is because of the number of sides. Now the last thing is, when you do this figure, you should also put in your hidden detail for the creases. These creases are the folds that are made when we fold the shape together and we make the actual 3D object, three-dimensional object. So these are the folds, are the parts of our pyramid. Now what I'll do is I'll just try to copy this, and then I'll try to rotate it a bit. And now this edge that is here, now this would be our site. So what I'll do is I'll actually pull it down to the plan view to show you where this side would go. So this 0 to 1 edge, if we really had to make this piece, it should line up with this side over here. It is not snapping the way that we want it to snap, but it should come there, and that will be our first edge, and then the other edges should come along. So we have here roughly our development of this pyramid. So you should know, when you take a look at the development, what type of figure it is based on the number of sides at the bottom. If it has hidden detail, you realize that the cones and the cylinders do not have hidden detail for those creases, for those edges, but the prisms and the pyramid, they have hidden detail because they have corners. So we will stop the video here.